Series is formed by adding the terms of a sequence. An example of an infinite sequence is term 1 is 0.3, term 2 is 0.03, and so on. The corresponding series S1 would be the sum of one term, which, and if you're listening to this, you can't see me covering up, but I'm covering up these terms here. S2 would be the sum of these two terms, S3, three terms, S4, and so on. So for example, what is S1? 0.3. What is the sum of two terms? 0.33. What about the sum of three terms? 333. Four terms. What is the limit as n approaches infinity of the sum of n terms? Okay, so it'll be 0.3 repeating, okay, which we can write like this, or like this, 1/3, right? 1/3 is 0.3 repeating. So we know that since the limit of this is this infinite series 0.3 repeating, which is 1/3, we say the sum of the series is 1/3. All right, now if an infinite sequence, S1, S2, S3, up to Sn, of partial sums of the series, T1 plus T2 plus T3 plus Tn, etc., has a limit L, that is, that this exists, okay, that there is a limit of S sub n as n approaches infinity, it is L. Then we say the sum of the infinite series is L, and we write this notation, which you didn't see, right? You've never seen that? It's because your education is now inadequate at the 30 level. You're supposed to know this. Okay, so we got to cover this. This is called summation notation, okay, or sigma notation or summation notation. That's an uppercase sigma, which is Greek. And so the way that that works, let's see, where do we have some room? We'll do this down here. So what I say is it's the sum, and you may have seen this because in Excel there's a formula for adding up. Like if you want to add up a row or a column or something, there's a little sigma there. You can use that. If you click on that, highlight the cells, it'll just sum them up. So it's called summation notation. So if I say the sum where n starts at 1, this is your starting value. You're going to start with n equal to 1, and let's say we go from 1 to 5 of t sub n. That's simply a shorthand for writing. So what you do is you start and you say, okay, we're going to start with n equals 1, which will be t1. The sigma means to sum up or to add, so we go plus, and now we increase n by 1 to 2, so it becomes t2 plus, and then we increase n by 1 again. So this is its starting value, and it always goes up by 1 until it reaches that value. So plus t4 plus t5. Okay, so that particular notation, the sum as n goes from 1 to 5 of t sub n is, and this is the expansion of that, so it's t1 plus t2 plus t3 plus t4 plus t5. Okay, if we say change this, so I could also do the sum of n equals 3 to 6 of t sub n, and then I would start with t3, right? I'm starting with n equals 3. This is my starting value. This is my ending value. And it's inclusive, right? So it starts with t3, and it ends with t6. Okay, so it would be t3 plus t4 plus t5 plus t6. So here we're doing the sum as n goes from 1 to infinity of t sub n. So that would look like n equals 1 to infinity of t sub n would be t1 plus t2 plus t3 plus dot dot dot, just to indicate that this is going to continue forever. Right? So that's what this is. Well, so then L is equal to the sum of this infinite series, right? T1 plus T2 plus T3 plus T sub n. So keep going forever. So for the one we were looking at, that's where we know we get 0. You're always just going to be putting a 3 on the end, right? Because we're going down. Right, any questions about what the limit, how we found that limit, or what this sigma notation means? Nope, good. In this course, we are mainly concerned with geometric series. Recall that a geometric series has a, what's the characteristic of a geometric series? I'll start you off. Constant. You could give me the word difference, but that wouldn't be right. So instead, constant. It's not even on there anywhere. It starts with an R. Ends with an ratio. Horatio. Yeah. It's a constant Horatio. Between successive terms, which we denote with the letter little r, and the general term of a geometry. You've forgotten this? Like, you just wrote the exam, like, what, weeks ago? You're going to get the results, like, next week. Probably. Next week. Usually after Family Day. Can't say for sure when. And yeah, you'll get it mailed out. Yeah, and it's coming from Edmonton. I mean, come on. Those horses can only move so fast in this snow. Okay. So, general term T sub n is T1 times r to the n minus 1. And the sum of the first n terms of a series is given by S sub n as T1 r to the n minus 1 over r minus 1, where T1 is the first term, r is the common ratio, n is the number of terms. Okay, for each geometric series, state the value of the common ratio. So we're going to figure out what is r. State the values of S sub 1, S sub 2, S sub 3, and S sub 4. So the sum of one term, two terms, three terms, four terms. And state whether each series is convergent or divergent. Okay, you know that. Have you done that? You did. Yeah, you've done that. Right? I know you did infinite. You've done sums of infinite series. So if the series is convergent, predict the value of the sum of the infinite series. And if it's divergent, then it doesn't have one. You're not going to predict anything. Okay, what's the common ratio for this series? Times 2, right? So how do we figure it out? We take a term and divide it by the preceding term. So we take 4 divided by 2 is 2. We take 8 divided by 4 is 2. We just kind of make sure it's the same. So yeah, this is a geometric series, although it says that each of them are, so we'll take their word on it. What is S sub 1? 2. What is S sub 2? 6. What is S sub 3? And what is S sub 4? And is this series convergent? Does it have a value? Can we predict the sum of the infinite series? No, they're getting bigger, right? So it is divergent. There is no sum to that series. Okay, let's do the next one. What is R? Negative 2. What's S1? 2. What's S2? Negative 2. What's S3? 6. What's S4? Negative 10. Convergent or divergent? Divergent. The numbers are getting bigger, but they're either bigger, positive, or larger, negative, right? They're going to flip positive to negative and so on, but they're always going to get bigger. What is R? 1. What's S1? What's S2? What's S3? Shouldn't be that hard. 6. What's S4? And it is not going to reach a limit as we keep going, right? So it's divergent. D. What is R? -1. What's S1? What's S2? What's S3? What's S4? And this series is divergent. And if you add them up, you're either going to get a 2, a 0, a 2, or a -2, right? That's the only possible sums, and they're just going to alternate. So it cannot converge, right? It cannot come to a value. What is R? Half. So in this case, I don't bother dividing by quarter by half. I just say, what do I multiply half by to get a quarter, and then a quarter by to get an eighth? So I multiply by half. What is S1? What's S2? Did I? 2 minus 2 is 0, plus 2 is 3, right? S5 should be -2, right? No, S5 would be 2. So it's going to go 0, 2, 0, 2, 0, 2, 0, 2, 0, 2. Or actually 2, 0, 2, 0, 2, 0. Okay, next one. What's S2? 3/4. What's S3? 7/8. What's S4? 15/16. Convergent or divergent?
Convergent.
This one is convergent. Where will it converge? 1. So convergent. And then we can say S, the sum at infinity, is equal to 1. Okay, so our partial sums, the limit of our partial sums as we keep going is going to be 1. Will we ever get to 1? No. We'll get really, really close, though. What's R? -2/3. What's S1? What's S2? It's the easy one. 1/3. What's S3? 7/9. You could say it louder. What's S4? Where's S4? Okay, I think I know. Shall I pause? 13/27. I was thinking the same thing myself. I heard two the same, so okay. So you know you're gonna add 27s, right?
Yeah.
Oh, thank you very much. Derivatives. Next unit. So you know you've got to change the denominator. So if I have 7/9, I'm gonna make that 21/27 minus 8/27 is 13/27. Okay, convergent or divergent? So it starts big, goes down, comes back up again, but not quite as high as the last time. Goes back down, but not quite as low as the last time. It's convergent, right? Yeah. Where will it converge? All right, we will come back to this in a moment. Some infinite series are convergent, while others are divergent. What are the values of R that make an infinite series convergent? So if you look on here, we have 2 convergent, the rest are divergent. What's a characteristic for R?
Between -1 and 4.
Okay, you know this from You said 20 thing or 30 thing? It's gotta be 20. You know this from 20-1, right? Yeah. Okay. Or another way to say this is that the absolute value of r is less than 1, right? So regardless of its sign, be it positive or negative, its magnitude must be less than 1. Okay. So if an infinite geometric series has a common ratio between -1 or 1, or the absolute value of which is less than 1, the series is convergent, and the sum of the series is given by t1 over 1 minus r. Now, do you want to go back and answer that previous question? T1 what's that, 3 5/3? 3/5. Or 0.6. Okay? 3/5, 0.6.
Oh, wait, 1 second. Anything under 1.
Okay, so we're just using the formula to work that one out, because it's not really obvious that it's 3/5. You'd have to keep going and then just kind of say, well, what are we getting close to here, right? Because it's going to bound. If you were plotting points, you'd be like here, and then I'm down here, but then I'm here, and we're going to approach some value as we keep going. And what is that value? Well, the formula tells us it's 3/5, right, or 0.6. Another notation is this sigma notation. The sum of the terms in a geometric sequence, right? T1 r to the n minus 1 is a term in a geometric sequence. So the sum of the terms in a geometric sequence, where you're adding them all up to infinity, is T1 over 1 minus r.
Yeah.
Okay, so now we can do this. Determine whether each series flow is convergent or divergent. So what's the first thing we got to find out? What is r? What's r? So is it convergent? Yep. And what is its sum? So the sum to infinity is 1 over 1 minus 1/2, which is 1 over 1/2, which is... Oh, hang on, sorry. First term is 72, right? Not 1. 72 over 1/2, which is 144, right? 72 times 2, right? Dividing by a half multiplied by the reciprocal. So 72 times 2 is 144. Next one, what's r? Matt, let's show some work. -2/5 divided by 5, which is -2/5 times 1/5, which is -2 over 25. Okay, now check that, right? So 5 times this, the 5 cancels down, you get -2/5. -2 over 5, 2 times 2 is 4, 5 times 25 is that, and the sign changes to positives. Okay, so it's good, right? Like I did it, and then I checked it, and it worked. So the sum to infinity is, here, not going to mess up this time. I'll put the actual formula down, right? It's T1 over 1 minus r. Now we can fill in values. So that's 5 over 1 minus 2/25, which is 5 over, 1 minus -2/25. So it'd be 27/25, which is, gets flipped, 125 over 27. Okay. Next one. What's R? So there's formula. What's R? Negative 1/4, right? Because this matches up, right? T1 is 3. R is negative 1/4. Travel meeting, tentative invitation. All right, we'll deal with that later. S sum to infinity. T1 over 1 minus R. 3 over 1 minus negative 1/4. 3 over, what's 1 minus a quarter? Sorry, 1 minus negative quarter is 5/4. And this works out to 12 over 5, right? And what's next? What's R? What's T1? Better figure that out, right? So T1 is 1, right? Because there's nothing in front of the R, but it's not nothing in the sense of 0. Therefore it's a 1, right? Because this is still of this form. So T1 is 1. R is 5/8. The sum to infinity is T1 over 1 minus R. 1 over 1 minus 5/8. 1 over 1 minus 5/8 is 3/8. And, oh, wait a second. You know what? T1 isn't 1. Because when n equals 1, so what's T1 really? It's 5/8. And when n equals 1, that's the easier way to find it. When n equals 1 here, that's a 0. That was a general form. This wasn't a general form. So this is not of this form. All right, so T1 is 5/8. Okay, so let's clean that up. Let's fix this. So it's 5/8 over 1 minus 5/8, which is 5/8 over 3/8, which is come on, the 8's cancel. 5 over 3, right?
Yeah.
Here, move that. Oops. So that's 5/8 times 8 over 3. And these guys cancel, so 5 over 3. Okay, so watch out, don't get tricked.
So wait, just how did you know that T1 and R were both 5/8? Like how?
Okay, so when n is 1, this will be 5/8 to the power of 1, which is 5/8. Okay, when n is 2, it's going to be 5/8 squared, which means I have to take the 5/8 and multiply it by 5/8, and then, that's kind of obviously R, but it's not in this form, right? It's not T1 R to the n minus 1, which is the general term in a geometric sequence.
If there's no T1, you should just plug in 1.
You should plug in 1. Yeah, not look at that and say, oh, well, T1 is 1. No, it's not. If that had been to the n minus 1, then T1 would have been 1. But it wasn't. Determine the value of x in each series below is convergent. So where do we start with this? Let's start here. What's R? 6x over 3, which is 2x. Now you might want to verify that, right? So 3 times 2x is 6x, times 2x will be 12x squared, times is 24x cubed. So, okay, we got the right ratio. What do we know about R for a series to be convergent? What's R? between -1. So for convergent, we know this is true. Okay, we've got r, so we know that 2x has to be between -1 and 1. Now we can't do this for 2x, so how do we get this just to be x? Divide by 2. Divide everything by 2, right? So we go through. -1/2 will be less than x, will be less than 1/2. Well, the nicer way of saying that, I like, is that, right? -1/2 and 1/2. So that's. The more I use parentheses notation, the more I like it, right? You're not worried about this. You don't have to worry about students throwing the directions around and giving you, I don't have to worry about seeing stuff like 5 is less than x and then having to translate it in my head to what's x then, right? In parentheses notation, it is here's the low, here's the high, and whether or not they're included and all of that good stuff. Okay, what do we do here? Okay, so same deal, right? Got to find R. Okay, what's R? Well, what's the expression we're going to use to get R? So we're going to take a term and do what? Divide it by the preceding term. So R is 1 minus x. What do we know about R? Okay, so let's do this like this. -1 is less than. Okay, what do we need in the middle? We don't want a 1 minus x there, we want x. So how do we get x? Subtract 1, right? Got to get rid of that 1. Okay, so subtract 1, subtract 1, subtract 1. Okay, so we're just subtracting 1 from everything, right? It's like an equation. It's not both sides in this, well, in this case it is both sides and the middle. Okay, but that's negative. I want to make it positive, so then this, what are we going to do? Yeah, so make things positive, but also then we have to switch the signs. So this says that x is between 0 and 2, which really we should say like this, or unambiguously like this, right? You can't not write this. You can't write some equivalent of this here. It's not. This is it. Okay. So this way I don't have to look at stuff like that and go, oh, it means x is between 0 and 2, and then I'm translating it to this. I've translated it to that. So x lies between 0 and 2. Okay. Not inclusive either, right? It doesn't include the 0 or the 2. All right. Almost there, right? This is it. This is it? That's it. There are other infinite series that are not geometric, but that still converge. Determine the value of the sum is equal, sum of n equals 1 to infinity of 1 over n minus 1 over n plus 1. So probably the best way to do this is just to write down a few terms and see what's going on, right? So we're going to start off by saying, okay, so the sum of n starting at 1 of 1 over n minus 1 over n plus 1 is, so what's the first value we put in for n? 1. So 1 over 1 minus, okay, so should I write it? Yeah, let's do this. So 1 over 1 plus 1 plus, next value we put in for n? 2 minus 1 over 2 plus 1. Next value?
Did it change? Did it change? Yeah, it's like different. It's just
And so on. Well, are you teaching?
No.
Yeah.
LOL. Not anymore, LOL. Yeah, I can handle it.
Yeah. Depends who you ask. Okay, so we've got a few terms, right? So that's 1 over 1 minus 1 over 2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus, and it's going to continue. Yes. All right. What's going to happen when we remove the brackets?
Those cancel.
And so on, right? So what's it going to equal? Ultimately, it's going to equal 1, right? Okay. Now, we don't get to use the formula for that. It's not a geometric sequence, but we can look at that and say, hey, there's a pattern. I have 1 minus a half, plus a half minus a third, plus a third minus a quarter, plus a quarter minus a fifth, and so on. Right? And those terms are always going to be canceling down, so we're really just going to end up with 1. There we go. Couldn't disappear. And speaking of disappearing, that's that.